everyone, welcome back to the Math Society. So this week we'll be going on to do some past paper questions from Chapter 6, which is logs and exponential functions. So let's start with the first question. So it is to find the exact solution of 3 power 2x minus 3 power x plus 1 minus 4 equals 0. So we know that we will need to substitute to solve it. So firstly, we'll let y equals to 3 power x. So this is 3 power square x, so we know that's going to be y squared. And then 3 power x plus 1 is 3 power x, and then it's 3 power 1, right? So it's 3 and 3 power x is y, so it's going to be 3y. Minus 4 equals 0, and then we'll just use the normal cross method. So it's just going to be 1, 1, 4, 3, and because minus is going to be like 1 minus 4 and 1 plus 3. So it's going to be x minus 4 and x plus 3. That's going to be equal to 0. So you're going to add x equals to 4 or x equals to minus 3. And then it's going to be 3 power x equal to minus 3. We need to reject this because it's impossible. And then it's going to be 3 power x equals to 4. And then you'll have LG x, LG3 equals to LG4. And then just erase this. And then x is just going to be equals to log 4 base 3. And then let's do question 2. So question 2 says that h of x is equal to 2 ln 3x minus 1 for greater than x equal to 2 by 3. So we have intersection at 2 distant points, and then we need to go y equal to h of x and y equal to h inverse x. We know that h inverse x is just going to be a mirror of h of x, so we'll find the intersection for h of x first. So when we find, we just know that 1y is equal to 0. Right, so 0 equals to 2 ln 3x minus 1. So it's going to be 0 ln 3x minus 1. You have e power 0, 3x minus 1. 1 equal 3x minus 1. And just 2 equal to 3x. And then x is going to be 2 by 3. So we know that it's going to intersect at x equal to 2 by 3 when y is equal to 0. 2 by 3. Let's draw a mirror line. Okay, I thought that's right, but in there we're going to draw our first h of x line. So we know this y equal to h of x. And then it's going to be a mirrored part, so it's going to be this way. Oh my god. I'll just do that again. And there's going to be y equal to h inverse x. And this is your graph. And we'll go to number 3. So 3, we were given that log x base 2 plus 2 log y base 4 is equal to 8. So let's try to find that first. We'll write it down first. Log x base 2. And we know that 4 is a square of 2, right? So we know it's 2 log 2 square y equals to 8. So that it'll be canceled out. So you have log x base 2 plus log y base 2 only equals to 8. And because it's plus, we can, and the same base, we can like multiply them. So it's 2xy equals to 8. And then you'll have xy is equal to 2 power 8. And we know that 2 power 8 is equal to, confirm, perhaps it's 256. Yes. So now we'll go to question B. So you need to use the substitution of y equal to 2 power x, or otherwise we need to solve this equation. So let's write this down first. 2 power 2x plus 1 minus 2 power x plus 1 minus 2 power x plus 1 equals to 0. And then it has to be y equal to 2 power x. So we know 2 power x, so it's 2x, so it'll be like 2y squared minus 2y minus y, maybe plus 1 equals 0. So you have 2y squared minus 3y plus 1 equals to 0. So we use the cross method as usual. You have 1, 1, and then you have 2, 1. So it's just plus, so it's going to be minus, minus. So it's going to be 2y minus 1, y minus 1, and that's going to equal 0. So y equal will be half, or y equals to 1. So we know it's 2 power x, so it's going to be 2 power x equals to half, or 2 power x is equal to 1. So we know that for 1, it's 2 power x equal to 2 power 0, right? So x can be 0, or is 2 power x equal to half, so it's going to be 2 power x equal to 2 power minus 1. So as usual, it's going to be x equal to minus 1. Yep, so now let's do number 4. So we need to solve the simultaneous equations. This gives you 10 power x plus 2y equal to 5 and 10 power 3x plus 4y equal to 50. So firstly, we can just write x plus 2y, so and we'll take log for 5, so it'll be like LG5. And then you'll have 3x plus 4y, and then you take the same thing as LG50. And we need to multiply this by 2, right? So it's going to be 2x plus 4y equals to 2LG5. So 2LG5 basically is like LG 5 squared, which is going to be LG25. So you'll have like minus, 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 so you have x equals to LG50. I say 2LG5 is the same as LG5 squared, so it'll be like LG25. So minus 25 LG. And then if it's minus, we divide them, so x is going to be LG2. So you have 2y equals to LG5 minus LG2. We have 2y equals to LG5 by 2. And then y equals to half LG 5 by 2. And then we'll do b, which is 2x power 2 by 3 minus x power 1 by 3 minus 10. So we'll just use the same method as usual. So it'll be like let y equals to x power 1 by 3. So it's going to be 2y squared minus y minus 10 equals to 0. And then it's going to be cross method as usual. 2, 1, you have 5, 2 to get 2. You have like 5 and then 2 because you get 4 and then 5. So it'll be like minus and plus. You have 2y minus 5. And then y plus 2 equals to 0. So you have y equals to 5 by 2 or y equals to minus 2. And then we have x power half, right? Equals to minus 2. Then it's where x equals to minus 8. Then you have x power 1 by 3 equals to 5 by 2. Just put it up. So we x power equals to so it's just be 125 by 8. So now question 5. So we have that log root b base a is minus half is equal to log a base b. So we'll try to rearrange the equation first. So we have like, because we know that it's root b, so we can take a half. So it will be like log b base a minus log a base b. So we have half. And then we'll try to make sure that the bases are like the same. So we have like half log b base a minus 1 by log b base a equals to half. And then we're going to substitute. So we're like let y equals to log b base a. So we're like half y minus 1 by y equals to half. And then we'll multiply by 2. So you have y minus 2 by y equals to 1. You multiply y again. So you get y squared minus 2 equals to y. So you have like y squared minus y minus 2 equals to 0. And then cross method as usual, you have like 2, so it's like 2 and 1. So you have y minus 2 and then y plus 1. And that's going to be equal to 0. So you have y equals to 2 or y equals to minus 1. And then we know that we substitute log b base a is equal to 2 or log b base a is equal to minus 1. So you have, b is equal to a squared or b is going to be equal to a power minus 1, which is 1 by a. And then we'll move on to 6, which is says that to solve the simultaneous equation, so like log 3 x plus y equals 2, and then 2 log x plus 1 base 3 equals to log y plus 2 base 3. So firstly, we know that if it's x plus y, we can just make it a cube, so it'll be like 3 square, sorry. Like make it square, I mean 3 square. So you have x plus y equals to 9, so which is your first equation. So like x equal you can have like y equal to 9 minus x, or x equal to 9 minus y. So and then for the second one is as usual, x plus 1 you have the whole square equals to you have y plus 2. And then you have x squared plus 2x plus 1 equals to y plus 2, and then you have x squared plus 2x plus 1. And then because y is 9 minus x, right? We'll have like 9 minus x plus 2. So you have x squared, 2x plus x. You have like 3x plus 1. You have minus 9 minus 2 equals to 0. So you have x squared plus 3x. You have 10 equals to 0. Then as usual, square method, 1, 1, 5, and then 2. So it's plus, so you have like plus, minus, so I have like x plus 5, x minus 2, then equals to 0, then x will be equals to minus 5, or x will be equals to 2. And then we need to find y. Y is 9 minus x, so y, 9 minus minus 5, so you plus them, so you get 14, or y equals 9 minus 2, which is 7. Okay, question 7. So now use a calculator. So they have to give you two equations, and we need to show that x cubed plus 6xy minus 32 equals to 0. And we have 2, so let's just try to make sure that we're gonna put the like terms in one side. So it's going to be like log y plus 1 base 2 plus log x log x squared. You have like base 2 equals to 3. So because it's plus, you can multiply them. So it's like y plus 1 x squared equals 2. And then you have like 2 power 3, so which is like 8. And then you have the second equation, which is log x plus 2 base y minus log y base 2 equals to 2. So it will be the same thing. So it's x plus 2 by y, and then 2 squares. 2 squares just equals to 4. Yes. And then if we want y, it's just x plus 2 by 4 equals to y. So you have the second equation here, and then you have the first equation here. So then we'll try to find that x squared, y plus 1, right? So x squared, so we're like x plus 2 by 4 plus 1. We'll substitute them, and that is equal to 8. So when we multiply them, let's do this first. So like x squared, x plus 2 plus 4 by 4, because we're going to have the same denominator, equals to 8. 8 squared, x plus 6 by 4 equals to 8. And then you'll have x cubed plus 6x squared equals to 32, because you multiply them. And x cubed plus 6x squared minus 32 will be equals to 0. So let's check if it is shown or not, and we see that it's the same and it's being shown. So you can just write shown, and then we'll go on to B, which is to find the roots of x cubed plus 6x squared minus 32 equals to 0. So let's say that let f of x equals to 0, yeah? Sorry, not 0. F of x equal to x cubed plus 6x squared minus 32. So then we need to find which one is the factor of it. So let's try to put 1. So if like 1 plus 6 minus 30, that's not going to be a factor, or like 2. 2 can be a factor. So you have like f of 2. So you have 2 cubed plus 6, 2 squared minus 32. So you have 8 plus 24 minus 32. So this is 0. So we know that therefore x minus 2 is a factor of f of x. Then we'll do the long division to find out its other root. So it'll be like x cubed plus 6x squared minus 32. Because if there's no x, we can put like plus 0x in the middle. Minus 32. And we know x minus 2 is a factor. Then you multiply by x squared. So you have x cubed minus 2x squared. And you plus them. So you have 8x squared plus 0x. And then you have plus 8x. So you have 8x squared minus 16x, but you plus them, so you have 16x minus 32. So then you'll just like plus with 16. So like 16x minus 16 to 32. So you get 0. So we now show that x squared plus 8x plus 16 is another root. So f of x is equal to x minus 2, and then x squared plus 8x plus 16 is one root. And if it's x and 16 is just 4, 4, and it's plus, it's going to be plus, plus. So you have a root of x minus 2, x plus 4, and then x plus 4. So now we know that the x values are 2, or x is equal to minus 4. Yes, and they ask for the roots as well, so we're good. And then C is to give a reason why only one root is a valid solution of the logarithmic equations and find the value of y corresponding to this root. So we know that if it's a negative, we cannot take the negative, as log cannot take negative values, right? So you can just say that x equal to 2 is the only solution. Log cannot take negative value. So then we need to find the y value. So let's go back to the y. And it's x plus 2 by 4. So y is equal to x plus 2 by 4. Y equals to x plus 2 by 4. So it's 4 by 4, which is equal to 1. Yes, so number 8. So it is given that f of x equal to 5l and 2x plus 3 for x greater than minus 3 by 2. So you need to find the range. So we know that for range, it's just going to be y belongs to all real numbers, which is r. And then we'll find the f inverse 1 and then its domain. So let's try to find f of x is equals to, first of all, it's equal to 5ln to x plus 3. So then you'll have like y, so it'll be like 5ln to x plus 3. You have y by 5, ln to x plus 3. And then you have e power y by 5, which is equals to 2x plus 3. And then it's going to be e power y by 5 minus 3 by 2 equals to x. So then we know now that f inverse x is going to equal to e power x by 5 minus 3 divided by 2. And then because we asked for its domain, we know it's going to be opposite of its range, which is y belongs to r as well. But then it's going to be x because its domain belongs to all real numbers. And then they asked us to sketch the graph of y equal to f of x and the graph of y equal to f inverse x. We know that for inverse, it's just going to mirror. So let's try to find the values for y equal to f of x when x is equal, when y is equal to 0. First, when y is equal to 0, 0 equals 5l into x plus 3. Oh wait, we can just do this. So y equals 0, x is just going to be like 1 minus 3 by 2. So which is minus 1, and x is equals to 0. Y is just going to be x is equal to 0. Y is just going to be 0. 5 ln 3. So let's just try to put it in the graph. So let's draw a mirror first. There we know it's going to be at -1, -1, x -1. It's going to be like -1 for a different one. Then draw this. And this is going to be y equal to f of x. And then, oops, I just do this. And this y is equal to f inverse x. So you have here, it's going to be 5 ln 3, yeah? 5 ln, oh sorry, 5 ln 2x plus 3. 5 ln 2x plus 3. There. In question 9, so they just asked us to write as the largest possible domain because we know that it's 2x minus 1 has to be greater than 0. 2x equals to 1, x greater than 2/2. So x just has to be greater than half. And then we need to find f of x in this domain. F of x is equals to 4 ln 2x minus 1. Yes. And then it's going to be like y equals to 4 ln 2x minus 1. And then y by 4 ln 2x minus 1 e power y by 4 equals 2x minus 1. You have e power y by 4 plus 1 by 2 equals to x. So it's just like f inverse x. You just change y to x, so it'll be like e power x by 4 plus 1 divided by 2. And then x is going to belong to half. And there. Okay, so now we're on to question 10. So we have 3 lgx plus 2 minus lgy. So we know we can make the same bases. So I have like 3 lgx minus lgy plus 2 lg10. So, and then we have these, so we can do lg x cubed by y plus lg 10 squared is 100. So like 10 squared by y plus lg lg 800. And then you just have lg, because it's plus and same base, you can just multiply them. It's cubed by y. And then we'll go on to question 11. So in question 11, it says that the population P in millions of a country is given by P equals to A multiplied B by T. T is the number of years after January 2000. A and B are constant. January 2010, the population was 40 million and had increased to 45 million by January 2013. So we have to show that B is equal to 1.04 to 2 decimal place and find A to the nearest integer. So we know that the equation is P equals to A multiply B power T. So first of all, it's like 40 millions after January 2000 in 2010, right? So it's like 40 millions. A constant multiply B power 10. So if you want A, it's going to be 40 by B power 10. And then we have another, which is 45 millions equals to A multiply B power time was like 2030, so it's 13 years. You have A is equals to 45 by B power 13, and you equal them. And then it's 45 by B power 13, so it'd be like B cubed equals to 45 by 40, because you divide in, if it's a divide, you can minus the powers. So B cubed is going to equal to 9 by 8 if you simplify them. So instead of B cubed, B is just going to be, or you can just do a cube thingy, which is, it's basically 2 by 3, but it's E cubed is going to be is equal to 1.040. So around 2 decimal places, you have to give it in 2 decimal places, right? So it's 1.04. So we've already showed that we get the, show that B is equal to 1.04. And now we're gonna find A. So A is just 45 divided by 1. B power 13, so 1.04 power 13. Which is just 27.02. But they say it's like nearest integer, so it's just going to be around 27. And then they tell us that to find the population in January 2020, give your answer the nearest million. So we know that P is equal to A multiplied B power T. We know A, which is 27. We know B, which is 1.04. T, we know it's like 20 years. So just multiply them. 27 multiplied 1.04, the whole power 20, which you will get 59.16. So does that give you your answer to the nearest million? So if it's nearest million, it's just going to be around 59 million. And then C is that in general, for sure, will the population be over 100 million for the first time? So it's the same. So it's going to P equals to A multiplied B power T. But now we know like what's the million that we're going to have. So it's going to be like 100. So we just want to know the time. 27 is our constant, 1.04. And then we just want to know the time, which is T. So firstly, we'll divide. And then you have 1.04 power T. So T, so it's just going to be LG 100 by 27. So you'll have T LG 1.04. And then T, you just divide LG 100 by 27 with 1.04. You get 33. I'll just write this step for you, which is LG 100 by 27 divided by LG 1.04, yeah? And then you'll get around 33.38. But then we just want to know, be over 100 million. So we'll just round it off to the bigger integer, which is going to be 34 years. So then we start at 2000. So it's just going to be the end's going to be 2034. So number 12, this says that the number of B bacteria is given by B equals to P plus Q e power 2T. And P and Q are constant, and T is time in weeks, and initially they're 500, which increases 600 after 1 week. So we write two equations to find P and Q as usual. So you have 500 was the initial, right? 500 was the initial, and it's like equals P plus Q e power is just going to be like, because it's initial, it's going to be 0, so it's just going to be 0. So you have 500 equals to P plus Q. So that's going to be your first equation. And we have 600 after 1 week. So it means 600 and then P plus Q e power 2, and then 1's just going to be like 2, but yeah, 600 equals to P plus Q e squared. And then 2500 equals to P plus Q, and then we'll minus them. So we have 100, and then you just have like Q e squared minus Q, because P and P's are going to cancel out. And then it's 100 equals to, we can take out Q, so like e squared minus 1. And then Q is just going to be specified. So you get 15.65, but we'll just round it off. They didn't specify anything, so you can just round it off to one decimal place, which will be 15.7. And now we want P. P is equals to 500 minus Q. So it's just going to be 484.3 in one decimal as well. So we have the two constant values, P and Q. And then B is to find number of bacteria present after 2 weeks. So we have, it was P, or B equal to P plus Q e power 2T. And then we have P was 484, I believe, 484.3. Was Q was 15.7. E power 2, and then T was like 2, so it's just 4. 3 plus 15.7 multiplied by e power 4. So then you'll get 1,341.4 bacteria. Oh, it's 49, so you can round it off to like 100,341.5 bacteria. Yes. And then we have the find the first weight in which the number of bacteria is greater than. So it has to be greater than this. So it's 1. Okay. Then it has to be greater than 1. 0. 5 zeros. Oh, I'm sorry, 6 zeros. Has to be equals to, we have P plus 44.3 plus Q e power 2t. So we're going to divide it first. So we're going to divide 456 divided by 484.3. You have 2,000. And then, oh, sorry, it's going to be like 1, 2, 3, 4, 5, 6 minus 2, 3, 4, 5, 6 minus 484.3 divided by 15.7. And that's how you get e power 2t. So it'll be 1,000 minus 484.3 divided by 15.7. You get 63691.828 equals to e power 2t. And then to get 2t, we're just gonna log it. So it's gonna be 11.061. So t, just divide it with just 5.53. So you just take the next nearest, so it'd be like around 6 weeks. And that's it for today's video.